Hello everyone, I'm Gavin Wang from Inspur. I'm in charge of the Inspur Open Compute Architecture design. I'm very honored to be invited in the meeting to share some information from Inspur side. What about the Open Compute Architecture, what's the value, and what's the goal. So first, let me let you know what is Inspur. Inspur now is the current world 3 for the computer vendor in the worldwide. We are #1 in the China. We focus on the cloud server and the data center solution to our customer. Inspur now currently we joined the industry open compute architecture. We joined the ODCC, OCP, and Open 19. This page is showed Inspur is the only server vendor to enjoy current all the open compute architecture product. Maybe someone will ask why current industry, why there have so many open architecture. My answer is maybe demanding and customer requirement driving the architecture. For example, this is China ODCC rack standard, and this is OCP, just lead by the Facebook. And Microsoft leads Olympus rack scale, and LinkedIn for the Open 19. So currently, our goal is working with the customer based on the customer requirement. We help customers stronger and makers stronger too. So we think open platform make ecosystem more open. So currently you see this is current all our current customer from the China and worldwide. So currently why we do the open design platform from our view is we can accelerate in new technology and innovation. We can help customer to decrease the cost, the TCO for their data center. And we can help customer to saving more the power consumption. And we can, because we can just provide the design database for the customer, we can make some like the small business customer and some the tier 2 customer to easy to join the OCP community. And currently, our Inspur is focused on the open hardware. We can help customer build some data center. And also, we currently contribute our rack level management based on the Open BNC and the Redfish. This is our the goal for the open platform. Currently, we have a lot of successful cases based on the different customer. We have, you see, we have a lot of current design case. For example, we have, this is not mainly focused on the Hadoop, and this is focused on the high density compute. And we also provide some other, like GPU, like PCIe switch, like a SAS switch to help customer build some the pooling resources solution. So based on that use case, we provide and build the design base, both on the architecture and the compute and compute storage AI schematic design. And we also build for the interconnection pooling and also for the rack management. Based on that, we can contribute or some the design to the OCP community. And but if customer have some special requirement, we can just use GDM, just joint design method to help some the customer based on their detail and their real requirement. So for OCP, currently Inspur, we just provide a whole the right level solution. First is compute. Currently, we have 4 kinds of compute node. All these compute node, we use the converge architecture. You see, all the design we base on the same motherboard. Just do the same motherboard, same baseband. We can just lower the design time and cost. And also we can improve the quality. Based on the same motherboard, we can just do some quick design over the mechanical parts to meet a different customer requirement. So this product is we focus on the I/O balance. So in the front, we can provide 2.5 and 2 PCIe slot in the front. All the PCIe slot is from the different processor. We can balance the system resources. And this node, we focus on the high-O application. In the front, we can provide a full 2.5 drive for the data acceleration, and we can provide 3 additional slots for the high-O expansion. This node is based on the 1 OU form factor. We mainly focus on the density compute. And this is our energy efficient product. So in the front, we can provide 1 3.5 drive and 2 by 16 I/O expansion. So from the second product is the storage. This is a new G board product. It's based on the 2U form factor. It's a 2 drive tree design. So total, we can support 34 drive for all the system under the 2U form factor. So currently, this is the most high-density solution currently. Also, we can use some of the SAS switch to build the SAS pooling for the customer. This is, currently AI is a very hot point in the industry. So we just build our full AI product. It's a GPU box. It's based on the 4U form factor. We can support the 16 PCIe form factor GPU in whole the system. We provide the very flexible architecture. So we can connect to the multi-node based on the different customer requirement. And also we can use the PCIe switch technology to help customer to build the GPU resource pooling. So the industry and this is AI is just more and more close to our life. So from the beginning, so the AI is mainly focused on the image and the speeds. But currently, AI will transfer to more application for the finance and the medical and smart enterprise society and multi-drive car. And also for the weather forecast and oil and gas application. So based on that, so we provide the whole AI OCP rack solution. We use OCP form factor compute node and our OCP form factor GPU node to build all the AI rack solution. So also we can use a PCIe switch to build the GPU pooling. So why we use the pooling? There's some advantage. As one advantage is we just can lower the latency compared to the traditional architecture. And also we can just do some of the cost optimized by the 5%. And also we can just increase the compute density compared to the traditional architecture. So just as I said, so currently our product provides a very flexible architecture. We just use a 2 layer of PCIe switch technology, the up layer and the down layer. The The long layer we just divide for the full group. Each group we just connect to the full GPU. And the upper switch we just can connect to the different multi-compute node based on the different customers' application. Besides the hardware, currently we are working at a whole rack level of management solution based on the Open BMC. Currently, you see this is our YPI for the whole system level management. And this we all based on the open BMC and the open Redfish. And currently, we can provide some firmware update for all the component in the rack level. We can update the CPLD, FPG, and the bells, and some mainly focus on the key component for the rack level. And we can provide some diagnostic capability. We can get all the important information from the key component. Currently, we are already working on that. We will contribute later. We will contribute the Open BMC whole level solution to the OCP organization. And also we working with some the other customer to do the open platform. This the case we working with Open 19. So currently this is some product already MP compute and storage. There's the next generation. Yeah, we call it converged architecture. Why we call it converged architecture? We use the same architecture. You see, this is based on the 2U. We can both support to the storage and the flash. We can support the ruler or the newest NVF1. And also use the same architecture. We can support provide the AI solution for the training and or the inference. Okay, next I will invite our encourage admin to do some Inspur AI product introduction.
Hi everyone, my name is Tael from Inspur support team. I'm located in Taiwan. And Gavin just told me he will spend more time and reduce mine, but I think I still need to spend much time here. So I think that AI machine is running many years, and most of the a lot of data generated by users from drive, space, and lots of computer. And okay, before the data be processed, the data is just data, so we need some process to become it to useful information and use the different algorithm, and this will provide different algorithm based on the current solution, current power solution. And here is the most popular application here. You know, Taiwan, in the Taiwan area, we will face about 25 to 30 typhoon to Taiwan area. So the weather forecast is really important to us, because if we can do some prepare, we will get trouble. And transportation. Do you guys know how many camera in China deployment? it is about 200 million camera in this year, and maybe we will reach about 500 million in next 2 years. And the China government had do a very interesting experiment. They can find a person in a person come from other country in 10 below 10 minutes. That's very interesting. And also there are a lot of applications need our AI engine. And this data is not the latest one because it just lets you know the argument, the Microsoft argument, AlexNet is only 8 layers, and after 3 years it becomes 152 layers. It's 90 times increase. And Baidu applications they recognize, and it also 10 times increase in 3 years. I think it's more in currently. And this page shows, this page shows the Inspur is the #1 provider. Not only the human, it's also the revenue, and you can see that the total of the rest company, the total number is over the other company total. And Inspur also is not only provide the hardware, the AI system we provide performance one, and also capacity, and also the pooling. We can you can if you have interest, you can contact. We have a product manager here. He can show you our product very detailed. And besides the hardware system, we also provide a management suite like the AI station, TIs. Those application is very popular in China company. And also we provide optimized frameworks like the CAP, MPI. Is based on the CAP to develop Inspur version, and it's really optimized framework. And also we provide vertical AI solution service. And following a few pages, I will introduce our AI system. The HS5 is the most powerful density AI server. The architecture here is we use two not two. You can see where is the point here. This is the AU server, right? Okay. It's each AU system including two midplane AV including the A GPU server, a GPU chip. So you will see 16 Tesla V100 GPU inside, and we use the next solution. We use the same motherboard design to a following system. That's why we can build many systems in a very short development period. And this is a standard 2U system. This is a very high density system in 2U. We have this is this is okay. This is the NVLink version GPU. We also have a PCIe standard PCIe version GPU solution in the same form factor. And also this the NF556AM5. This is also a very high density GPU system, but also it including many storage here, so you can use it to run the AI system, also the storage system. And for this product, it's used NVIDIA P4 GPU. It's not like a high performance GPU, but for those something like not a hospital or small company, they like this kind of product because they can have a low capability to deal with their business. And we also provide a rack solution here. We use the same PCI switch in the ODCC and OCP, so we can provide we can provide a solution both on the ODCC and OCP very fast. The ODCC already production, but the OCP one is ongoing, but it should be very soon. Okay. The following page is sharing you guys how we work with the company in China to help them to use our product to develop their business. This is in car insurance company. Sorry. They used our HS2 to optimize their business, and they create very much photos in their database, and they save many human resources in their company and reach their business very fast. And image identifier accuracy is reached to 99%, even more. So the system, the software solution and the hardware solution we provide is really really useful. Okay, this is another case. Yeah, this is another case in China Mobile. I'm Dahua and the financial-based company. Yeah. This is the latest page I enjoyed today. Thank you.